Hi everyone. We're continuing with the June Common Test, which was written in the province of Gauteng in the year 2024. This video will mainly focus on Euclidean geometry. Okay, we are given the diagram below, and we are told that O is the center of the circle. Immediately, guys, whenever they tell us about the center, I need to focus on two theorems. Together, the first one is the one that says a line drawn from the center to the midpoint of a chord is perpendicular to the chord, and its converse that says a line drawn from the center perpendicular to the chord bisects the chord. Okay. And then the second theorem should be the one that says the angle at center is 2 times the one at circumference. Are you together? So here there's no line drawn from the center to the midpoint. Simply means we will ignore the first theorem and its converse. We'll focus on the one that says the angle at center is 2 times the angle at circumference. Why? Because I can see that there is an angle at center which is subtended by chord AB, and the same chord subtends angle D1 at the circumference. Simply means angle D1, angle O1 is 2 times angle D1. Okay, let's continue. A, B, and D are points on the circle. BC is a tangent to the circle at B, and angle DBC is 22.5. Okay, immediately when they tell me about a tangent, I need to focus on two theorems as well. The one that states that the angle between the tangent and the chord is equal to the angle subtended by the chord at the circumference. Are we together? Basically, it's tan chord theorem. And secondly, I need to focus on the theorem that states that the relationship between a tangent and a chord are always perpendicular. Simply means whenever a tangent meets a chord, I'll have 90 degrees. Are we together? The other one that states that the angle between the tangent and the chord, if CP is a tangent, this is the angle in between. Are we together? This angle will be equal to angle A1. Why? Because A1 is subtended by chord DB. Okay. Chord AD is produced such that CD is equal to PD. When CD and PD are equal, that thing makes triangle CBD to be isosceles. Why? Because CD and DB, which are equal, are opposite sides of a triangle. So if this angle here is 22.5, this one will also be 22.5. Are we together? Okay, let's answer the questions now. Let's answer the questions. Okay. Determine given reasons the size of angle A1. Please remember that we were told that CD is equal to PD, right? This was given to us. I can therefore conclude that angle C is also equal to 22.5 degrees. The reason is because we have an isosceles triangle, and this fact is the one that makes this triangle to be isosceles. This fact. Right, together. So I can simply say angle D1 is equal to angle C plus angle what? Angle DBC, which will give us 22.5 plus 22.5, and then we'll have 45 degrees as angle D1. I just realized that I started answering the second question, but it's fine. We'll go back to the first question, guys. Excuse me. So this is how we found the angle D1, right? Angle D1 is an exterior angle of triangle of triangle BCD, angle D1 is an exterior angle of that triangle. Ne? Whenever you write this statement, please don't forget to write the reason. Let me write it in blue. This is an exterior angle of a triangle. Alright, together. Okay, and now let's go back and find A1. A1 will be equal to 22.5 degrees. Why? This is tan chord theorem. The angle between the tangent and the chord. Okay, this is the chord we are talking about, ne? And as you can all see that this chord subtends angle A1 at the circumference. So angle A1 will be equal to this angle here, according to the tan chord theorem. According to the tan chord theorem, now they want us to find the size of angle B2. Okay, please note that, let me erase just to create some space to write. Please note that the tangent CB is perpendicular to the radius OB. Why? Because a tangent and the radius are always perpendicular. You just need to write 10 radius there. Right? So this thing simply means that angle CBO is equal to 90 degrees. This angle is 90 degrees. Why? Because CB is perpendicular to OB. Are we together? But angle CBO is made up of the 22.5 degrees plus angle B2, which is 90 degrees. Therefore, angle B2 will just say 90, excuse me, just say 90 minus 22.5, and then we'll get our 67.5 degrees. Okay, and then now they want us to find the size of angle O. Angle O is 2 times angle D1. And we found angle D1 to be 45. Simply means angle O will be 2 times 45, which will give us 90 degrees. And the reason behind this thing will just say angle at center is 2 times the angle at circumference. The angle at center is 2 times the angle at circumference. Okay, so B2 is 67.5 degrees. Let's not forget that. Now I'm supposed to show that 8.2, I'm supposed to show that OA is parallel to BC. Okay. Yes, OA is parallel to BC. Why am I saying that? Because we have an angle of 90 here. We also have an angle of 90 here. So that means these two angles are alternating and these two are parallel. Like, are we together? So we can just say since O1 is equal to angle CBO, both angles are equal to 90 degrees, I can therefore conclude that OA is parallel to CB. The reason I can just say because the alternating angles are equal. The alternating angles are equal. And I need to write those angles. I'm talking about angle O1, which I'm saying is equal to angle CBO. That's how we've answered the question. Okay, if it is further given that the radius of the circle is 12 units, find the length of BC. Our radius is 12 units. That means I have 12 here, I have 12 there. They want me to find the BC, but please remember that these two angles are equal. Why? Because both of them are equal to 22.5 degrees. So simply means that triangle ABC is an isosceles triangle. So this guy will be equal to this one. Are you together? So if I can find the length of AB, that length will be the same as the length of BC. How can I find the length of AB? Please note that we've proven that this guy is 90 degrees, right? So that simply means we have a 90 degree triangle, right angle triangle, and AB is the side opposite the 90 degrees. It simply means that AB is our hypotenuse. So I can simply say AB squared is equal to OB squared plus OA squared, right? This thing is true because of the Pythagoras theorem. Are you together? So AB squared is equal to OB. What is OB? OB is 12 units plus another 12 units squared. So AB squared will give us 2 times 12 squared. Therefore AB, just put the square root on both sides. I'll get 12 multiplied by root 2. So the length of AB is 12 times root 2. That means this side will be 12 times root 2 as well. So therefore the length of BC is 12 times root 2. 12 times root 2. Okay, now we'll move to question 9. Okay, we are told that in the diagram below, the diameter BE of the circle O is produced to D. Okay, once they tell me about the diameter, 2 theorems need to click in my mind. The first one is that the angle subtended by the diameter at the circumference is equal to 90 degrees. Are you together? Secondly, whenever a diameter meets with a tangent, they will always form an angle of 90 degrees because they are perpendicular. Are you together? So once I hear the term diameter, I need to know that, okay, that diameter guy subtends an angle of 90 degrees at the circumference. Okay, we are told that DA is a tangent to the circle and CD is perpendicular to BD. Immediately when I'm told that a line is a tangent, I need to focus on 2 theorems with regards to tangents. The first theorem states that for the first theorem I need to focus on tan chord theorem, and then for the second theorem I need to focus on the tangent and diameter or radius relationship. In this case, our tangent does not meet the diameter or the radius, so that means we will mainly focus on tan chord theorem. Are you together? Okay, so tan chord theorem simply states that okay, let me just shade this angle here will be the same as this one. Are you together? Another one is that this one here, the angle here will be the same as this one. Are we together? Okay, now let's start answering some questions. Prove with reasons that A, B, C, D is a cyclic quad. A, B, C, D is a cyclic quad. Okay, whenever you show that a shape is a cyclic quad, there are three things that you must prove one of the three things. Né? Firstly, if you can show that the opposite angles of that particular shape are supplementary, therefore you can conclude that that shape is a cyclic quad. Are you together? Or if you can show that the exterior angle is equal to the interior opposite angle, therefore you can conclude that that particular shape is a cyclic quad. Lastly, if you can show that the angles in the same segment of that particular shape are the same, then it simply means that that particular shape is a cyclic quad. In this case, let me erase things I don't need. Okay, in this case, if I can show that angle A2 is equal to angle D2, I can therefore conclude that this thing is a cyclic quad. Okay, A2 angle A2 is equal to 90 degrees. This is an angle in a semicircle. Angle in a semicircle. All together. So if this thing is an angle in a semicircle, it simply means that angle A2 is equal to 90 degrees, right? But remember that D2 is also equal to 90 degrees. Why am I saying that? Because I was told that CD is perpendicular to BD. Are you together? So I can therefore conclude that angle A2 is the same as angle D2. Are you together? Why am I saying that? Because both angles are equal to 90 degrees. So now I can therefore conclude that A, B, C, D is a cyclic quad. Is a cyclic quad, right? And the reason behind that is because the angles in the same segment are equal. Which angles are those? Angle A2 and angle D2. Angle A2 and angle D2. Okay. Prove with reasons that angle that BD bisects angle ABC. BD is this straight line here. I must show that it bisects angle BDC. Simply means I must show that this guy is equal to this guy. Okay, how can I do that? Let me erase that at the top so that I can create room for writing. Okay, how can I do that? Okay, angle A3, this angle here is equal to angle B1 because of the tan chord theorem. Are you together? And angle A3 is also equal to angle B2. These are angles in same segment. Since I have proven that this shape is a cyclic quad, right together. You can see that a cot DC subtends angle A3, and cot DC also subtends angle B2 at the circumference of that cyclic quad. Right together. So I can simply conclude that angle A3 is equal to angle A3 is equal to angle B2 because they are in the same segment. Angle B2 because they are in the same segment, né? So I can therefore conclude that angle B1 is equal to angle B2. Why? Because both angles are equal to angle A3. Are together. So I can therefore conclude that line BD bisects angle ABC. And the reason is simple. The reason is because angle B1 is the same as angle B2. Are we together? Okay, now prove with reasons that EC is a tangent to the circle OEF. Where is EC? Okay, this is EC. This line there is EC, né? If this line is a tangent to the circle that passes through OEF, it simply means that my duty is to show that angle E3 is equal to angle O1. That's all I need to do. Okay, so if I can prove that angle E3 is equal to angle O1, I can conclude that EC is a tangent of angle OEF. When they say to you prove that a line is a tangent, most of the times you must prove the tan chord theorem, which is true, né? So in this case, let me erase the top. Okay, I know that angle E3 is equal to angle ABC. Are together? This thing is because angle E3 is an exterior angle of cyclic quad. I'll just write CQ, cyclic quad ABFE. Right together. This thing here is a cyclic quad, right? And E3 is the exterior angle of that cyclic quad. Are we together? So since I know that angle APC is made up of angle B1 plus B2, but both of those angles are equal, I can simply say angle E3 is 2 times angle B2. Are we together? Okay, and now O1 is 2 times angle B2. Why am I saying this? This is an angle at center, and that angle is 2 times the angle at circumference. Are we together? So I can therefore conclude that angle E3 is equal to angle O1, and this thing is true because both of those angles are equal to 2 times B2. Are you together? So I can therefore conclude that EC is a tangent to the circle OEF, to circle OFE. And the reason behind that is because the Tan-Cot theorem is proven there. Are you together? So now I've shown that line EC is a tangent to the circle. Okay. Question 10. Question 10. The first question, I must prove the proportionality theorem. Excuse me. First question, I must prove the proportionality theorem, ne? Okay, you can't prove the proportionality theorem, guys, without not just proportionality theorem, any theorem without constructing lines. Are you together? Okay, the first thing you need to do whenever you prove this theorem is to construct the height of a triangle. Are you together? And that height has to be perpendicular to one side of a triangle, ne? Why am I constructing heights? I'm constructing heights because I'm going to use areas of a triangle. Are you together? For you to find an area of a triangle, you must find the height of a triangle. Are you together? And you can call this this H1. Are you together? To show that this is the height, the first height that you've constructed. Another height you can construct is this one. It has to be perpendicular to the side of a triangle as well, right? And you can call it H2. Are you together? Okay, after constructing the heights, another lines that you can construct are lines. Let me just draw them in black. Must construct line DC and must construct line EB. Why am I constructing these lines? Because I want to focus on this shape as a triangle. On this shape as a triangle, right? I don't know why can't I write here. Yeah, I want to focus on that shape as a triangle and also this one as a triangle. Oh, I don't think about it, man. It's fine. I'll just use the way that I'm used to. Okay. I just wanna focus on this shape as a triangle. This shape is one triangle, and then this one is the other triangle. Why? Because I have those. I have this side as my base here, and this side is my base there. Are we together? So the sides that I do not need are side DE and side BC. So that means I must construct another side. Okay, after constructing here, guys, I can simply say I can simply find the quotient of triangle. Okay, I'll just say the area of triangle ADE. ADE is the triangle at the top, ne? All over the area of triangle BDE. Okay, the area of triangle ADE, ne? I'll simply say 1 over 2. 1 over 2. Since I'm focusing on ADE, guys, ne? I can take AD as my base, right? Please remember that the area of a triangle is always half base times the perpendicular height. Are you together? In this case, I can just take h1 as my height, multiplied by h1. Are you together? Same thing applies here. The area of triangle BDE, BD or DB is my base, and my height is still h1. Please remember, guys, if I have a triangle like this, my height will be like this. I would get it to be perpendicular to this side. So in this case, we have a triangle like this, and this h1 will be our height. Are you together? So here, both the halves will cancel. You have the same height. So this thing simply means that the area of triangle ADE divided by the area of triangle BDE can be written as AD over DB, right? Okay. Excuse me. Now I want to focus on the sides which are on the left, which are on the right hand side as bases. Are we together? Say the same thing we did here. Let me write on this side. Simply take the area of triangle ADE all over the area of triangle ECD or EDC. Are you together? I'll take 1 over 2, and AE, I can take AE as my base and H2 as my perpendicular height. On the other side, I'll take 1 over 2 EC as my base and then H2 as my perpendicular height. Please note that this will cancel this and these two will cancel, ne? So simply means that the area, okay, let me not force things. The quotient of the areas is equal to AE over EC, right? Okay. But if we can check, guys, here we spoke about the area of triangle ADE. Also spoke about the area of triangle ADE, right? So these are areas of the same triangle, but they are calculated differently. This thing simply means, let me write in black, the area of triangle ADE is equal to the area of triangle ADE. Are you together? So another thing we know is that the area of triangles which are between two parallel lines, the areas of triangles which are between two parallel lines are the same, are together. So we can simply say that let me write that at the bottom because I think there's a room there. The area of triangle DBE will also be the same as the area of triangle ECD. Are you together? So this thing simply means that the area of triangle ADE all over the area of triangle BDE will be the same as the area, because we are dividing two things that are the same, right? Area of ADE all over the area of triangle ECT or ETC. Doesn't matter how you name it. Okay, let me continue with ETC because I've started with ETC. Okay, but please remember that whenever we calculated the area of ADE over BDE, we found that AD over DB is equal to AD over DE, ne? Over DB rather. And then on the other side, we found out this is equal to AE over EC. So now we have proven that AD over DB is equal to AE over EC. Are you together? So this is how you prove the proportionality theorem, guys. Okay, now let's go to question. Excuse me. Let's go to question 10. Okay, question 10. In the diagram below, D is the center of the circle. A, B, and AE are tangents. A, B, and AE are tangents. Okay, we can see that these tangents, they come from the same point. So I already know what's a ha. They're equal in length. Okay, the diameter BG is produced to meet the tangent AE at C. Okay. BG is equal to DG. Okay. Since DG is the radius, it simply means that DB is also equal to GC. Okay. F is the point such that DF is parallel to AB. Okay. Prove with reasons the ratio of AC over FC. Okay, AC over FC, right, is equal to BC over DC. And this thing is true because of the prop theorem, ne? So therefore AC over FC is equal to BC. Please note that BC is 3 times the radius, which is UDG. Are you together? And UDC is 2 times UDG, which simply means that the ratio, because these two will cancel, the ratio will be equal to 3 over 2. So I'll just write 3 over 2 here. Excuse me. Okay. And then now I need to show that proof giving reasons that triangle ABC is similar to triangle DEC, ne? Okay. I'll simply say, okay, I didn't have to erase that. In triangle ABC and triangle DEC, ne? Okay, angle C is common. It's a common angle. Are you together? ABC. Angle B is equal to angle E1. Both angles are equal to 90 degrees. Right? So this thing will just make angle A to be the same as angle D. It's just an angle, or just a third angle of a triangle, né? Third angle of a triangle. So therefore, simply say triangle ABC is similar to triangle DEC. The reason is angle, angle, and angle. So now we've proven that the two triangles are similar. Okay. Please, guys. The theorem of similarity says that if two triangles are equiangular, are together, therefore those triangles will be similar, and hence the corresponding sides will be in the same proportion. What are corresponding sides? Corresponding sides are sides that subtend equal angles. Are you together? Okay, I will show you how we include these sides here. Okay, we'll firstly focus on triangle ABC, the bigger triangle. We'll check which side is subtending angle C. AB is subtending angle C, right? Excuse me. Which side is subtending angle B? Angle B is subtended by AC. Which other side is subtending angle A? Angle A is subtended by what? By BC. Are you together? And then now we'll go to the second triangle, DEC. Which side is subtending angle C? ED is subtending angle C, right? Which side is subtending E1? DC is. Which side is subtending angle D? That's EC. That's EC. Okay, so here I'll simply say, as you can all see, I have AB over something is equal to AC over something, which is equal to BC over something. Ne? I didn't write the division lines deliberately because I wanted to show that it has to be one side of the triangle divided by the side of the other triangle, né? And those sides has to be corresponding. Why are they corresponding? Because they subtend equal angles. The corresponding sides are in the same proportion, like this. Okay, we must show that DE squared is equal to that. Okay, we can just use the first two here, this one and this one, né? But guys, please, whenever you write this, né, you don't just write this and then keep your mouth shut, né? The reason should be this thing is true because triangle ABC is similar to triangle DEC. Are you together? Okay, and therefore we'll just focus on this one. AB over EC is equal to BC. No man, it's AB over AD, excuse me. It's AP over ED there. I did write ED, excuse me. And then BC over EC, right? I can cross multiply here. I will have AB multiplied by EC equaling BC multiplied by DE. DE and ED are the same thing, né? But please remember that DE is the radius. and we said that this line is 3 times the radius. Are you together? Another thing I want us to know is that the length of AB, since AB and AE are tangents from the same point, it simply means that AB and AE are equal. Whenever I see AB, I'll just put AE. Why? Because AB and AE are tangents from the same point. I have EC here. Okay. Please note that I said BC is 3 times the radius, and our radius is DE. So this thing simply means I'll have AE multiplied by EC is equal to 3 times DE. DE times DE is just DE squared. I can divide both sides by 3, therefore DE squared is equal to AE multiplied by EC all over 3. Now I've proven that DE squared is equal to that, né? Okay, lastly I need to find the ratio of the area of the areas of the quotient of the areas. Okay, what can I write? Let me write here. Area of triangle FDC over the area of triangle ABC. Okay, where is FDC? FDC and ABC. Okay, the easier way is to take the trigonometry roots, right? Let me rather erase here so that you can see properly what's going on. There is an easier way, guys, to do the trigonometry roots, né? But I will also show you the other route you can use by just using Euclidean geometry, but it will be longer. But I just want you to get used to it. Okay, so the area of triangle ABC, excuse me, I can simply take the sine of this angle right together, the sine of this angle, and then multiplied by the product of these things. So I'll say FDC is 1 over 2, and then I'll have what? FC multiplied by DC multiplied by DC sine of angle C, right? And then the area of the bigger triangle is 1 over 2, and then I'll have what? AC multiplied by what? Multiplied by DC. Multiplied by BC rather, as kiss. Sine of angle C, né? Okay, so this guy will cancel this one. This will cancel this one. And then we are left with FC over AC multiplied by DC over BC, right? Please remember that we found this guy to be 3 over 2. Are we together? DC and BC, The ratio of DC and PC, guys, PC is 3 times the radius. DC, and then DC is 2 times the radius altogether. So if you divide the two as well, DC and PC, you'll get 3 over 2 as well altogether, and then you'll get 9 over 4 as your ratio. This is the ratio of the areas, guys, altogether. I hope this thing makes sense, guys. Please stay tuned, guys, and wait for more videos. Oh, it's tiring.